Hello, everyone. Welcome to our session about latest and greatest in networking. Thanks for showing up. Good to see so many friends here in the audience. So we're going to have a great talk today. So I'm going to introduce the agenda for today. So we'll start with Azure networking, where it started and where we are today, our journey of Azure networking. And we'll also talk about lessons learned from operating such a big hyperscale network with you, so you can actually run your workloads in a more resilient way. And then we will talk about some new announcements, product enhancements that we have. We'll show you some cool demos. And then if you have time, we'll also get to Q&A. So to kick things off, I'm going to invite Dave Maltz, Corporate Vice President for Azure Networking, over here to kick things off for us.
Thank you very much, Narayan. And thank you all for coming to this networking breakout session here at Ignite. Thrilled to welcome you all. Networking has been a passion of mine for a long time. Having computers and data centers doesn't do any good unless we have a network to connect all of those things together to get information between those computers and out to our customers wherever they happen to be on the planet. Azure Networking is over 3,000 people and a global team all around the world that provides technology that covers everything from fiber inside of our data centers all the way out to massive distributed systems like Azure Traffic Manager and our domain name service that helps customers wherever they are on the internet, wherever they are an on-prem or a mobile worker, get access to those services that are running inside of our data centers. I'm going to share with you some of the tremendous amount of innovation that comes from this team. And then I'll hand back over to Ryan, who will tell you about some of the new things that you can do today to leverage these capabilities for your customers and for the services that you're building out. When I talk about Azure Networking, managing the network, we really are your one throat to choke for connectivity in Microsoft's cloud solutions. We design the routers, the switches, and the operating systems, the topologies and the connectivity that run inside of our data centers. We figure out how to connect data centers together so that you can have literally gigawatts worth of server capacity available to you wherever you need it around the world. We connect each of those Azure regions together with a WAN that Microsoft has custom designed and built from the ground up so that we can guarantee the quality of service that you'll receive as data moves across our network. We provide all the edge connectivity options that you need, middle boxes that can transform requests, Azure Traffic Manager to help your customers' requests find the closest, most available data center to process their queries, ExpressRoute, and all sorts of hybrid connectivity technologies so you can reach out and connect to your users or your on-premise data centers wherever they happen to be. We don't do a lot inside of the connectivity, but we do peer with hundreds of other internet service providers. We peer very deeply with all the other cloud providers at petabytes of connectivity, so you can rest assured that wherever your data happens to be and wherever it needs to go, we can get it there for you. And while we're not building eyeball networks, we do offer tremendous monitoring of how billions of eyeballs all around the world see connectivity back into Microsoft. And we use that data to make sure that we are directing customer requests to the data centers that are best. And this is information that we can make available to you so you can see how customers are experiencing your services on Azure as well. Now, this all didn't just come out recently. We've been working on this for decades. Our network designs themselves reflect over 15 years of operational experience building out and operating some of the largest networks on the planet. A couple of principles that we've learned. One, if having one device is enough, it's not enough. We're going to build broad layers, thick nests of links so that we always have enough redundancy and capacity even as things fail. We make sure that everything is resilient to failures, because as I'll talk about later, at the scale we operate, everything breaks. We have to make sure that our network is resilient even in the face of those outages. And it has to be easy to operate. It has to be easy to operate for us so that it can be resilient. And we need to make that data and ease of operation available to you so that the network can be like air. It's always there. It's always working. It's not something you need to worry about. We talk about Azure being a global footprint. This map here gives you just some sense of how we're present around the world. As Satya said, Azure is present in over 60 regions around the world. That translates into over 300 data centers. And beyond that, there are hundreds of more we call points of presence, or edge sites, where we actually meet between the Microsoft technology capacity and that of other ISPs. And that's where our middle boxes are placed, again, so we can guarantee good last-mile connectivity to your customers and your services. Implementing all of this is nearly 1 million network devices that we've deployed, managed, and operate the software on. Now, I talked a little bit about that WAN, that wide area network. Again, to give you some scale of that, we have over 225 POPs, those points of presence, where our network meets other networks, connected by hundreds of thousands of kilometers of fiber. Many people don't realize this, but Microsoft is one of the world's largest wide area networks. And the reason we do this is, again, so that we can guarantee the quality at which data will be served as it traverses across our network. And that's a network that provides over 2 petabits per second of capacity. So we have high confidence that no matter how large your data set is, we can get it from where it is to where it needs to be. Digging into one of those regions a little bit, the regions are where our wide area network and our connectivity to you, our customers, meets our data centers. If you look inside of each of our regions, you'll see many of them have availability zones, each availability zone being made up of 1 or more data centers. We use this design so that we can always expand our regions. Once you've started deploying in a region, we know that you want to be able to continue to expand there without having to redeploy elsewhere. And with our expandable design of regional network gateways and availability zones, we can make that available to you. When you look at network diagrams, you often see a line that connects 2 things together. I want to rest assure you that if you dig into that line, what you'd actually see is something more like that box on the right. You don't just see one device. You don't see one fiber cable. You see broad layers of network devices, densely interconnected with many, many links. That's the actual topology that sort of underlies our network topology. It's what gives us confidence that even if one link fails or one router fails, that's OK. We have these broad, redundant layers of links. It also gives us the ability to scale out capacity. If we need more network capacity in a part of our network, we just add and make these layers broader, adding links and redundancy as we go. That's enabled us to get this extreme scaling. We've been driving the industry forward from what used to be 1 gigabit links up to now 100 gigabit links, 400 gigabit links, and we're early adopters of the 1.6 terabit per link generation. We've designed and laid out our data centers and regions so that low latency is always available to you. Each of our regions is under 2 milliseconds round trip time in diameter, and each of our availability zones has under 1 millisecond round trip time in diameter. And those are numbers that you can use as you design your low latency services to then offer to your customers, while still keeping redundant information copied across multiple availability zones. The bisection bandwidth of one of our regions alone tends to be over 1.6 petabits. So again, no matter where data happens to be in one of our regions, you know that you can access it from any of the availability zones. And I'll talk about this a little bit later, but we use a lot of open source software in order to enable this regional resiliency and our global network availability vision. The network plays a big role in security. The network is on path between all customers legitimately trying to get at their data, and it's also the thing that's on path for any attacker trying to get at your data or your service to cause it harm. And so for that reason, as part of the network team, we work very, very closely with the security teams, and we offer many networking services that you can use to help keep your services safe. Microsoft's investment in security is over $20 billion over a 5-year period. There's over 78 trillion signals that come from our network and our other sensors in our data centers that we're integrating and analyzing every day to detect attacks or potential threats. And over 400,000 customers around the world are trusting Microsoft to help provide the security and services that their customers need. Zooming in a little bit on the networking side, almost 500 billion application attacks are blocked every day by Azure's Web Application Firewall. The internet truly is a hostile place, and you need to have a partner like Microsoft to help you defend services that are going to be out there on the internet. For example, over 3,500 DOS attacks every day get mitigated with no impact to our customers because of the extensive capabilities that we've put into our physical network and the services that run on it. And every month, over 1.5 trillion attacks, again, are being blocked by our Azure firewall, keeping applications and services hosted in our data centers safe. People often ask, well, how big is the Azure network? How can I think about it? One data point I like to give people is that every day our network carries over 15 exabytes. That's more than 2 terabits of data for every person on the planet. And I should also say, this is just what we call our front-end network, the network that connects our servers together with each other and out to the internet. It leaves out all of what we call our back-end networks, the networks that connect our AI supercomputers together and all of our training and inference clusters. That data is all on top of that. This is just data that applications or services are using to actually communicate between each other or out to customers on the internet. Now, operating this kind of infrastructure that's so business critical is a great and awesome responsibility. We say inside my team, quality is job number 1, along with security, and that's something we really take to heart. And so every service that we've built, we look at it from a lens of availability, reliability, and security. So go back to that wide area network. It's tremendously important that it be able to carry data to every place in the network. Operating such a network requires having a smart traffic engineering brain that's always there figuring out where the best place to send traffic across the network is. But any type of system like that has risks. If you tried to have one software system run your entire wide area network, well, that's one system that if it had a problem could result in a global outage. And so we provide resiliency against that by actually taking even our global traffic engineering brain and regionalizing it. We break it up into 7 geographies. So again, even if the worst were to happen and we were to have a problem in our systems, it would impact only a part of the total global geography. And we communicate information like this with you all so that you can design business continuity and disaster recovery practices for your customers and your services that leverage these mechanisms that we've built inside the Azure platform to make sure that your customers and their services stay up and running no matter what happens. When you operate a network at the scale we do, stuff breaks all of the time. We get about 20 fiber cuts a day in our network. And again, customers notice almost none of this because our traffic engineering systems take care of it. When you operate a network with the literally millions of links that we do, servers break, network routers break, and links break. And so we've invested heavily in large-scale data mining systems that actually leverage the same capabilities available to you as part of the Azure platform to pull in millions of signals a day, filtering through those to find millions of anomalies a day, and then run them through decision logic systems to identify the actual problems that need to be mitigated by our systems. And then about 99% of those can be handled within minutes by our automation. About 1% get kicked out to our human engineers who are on call 24/7 around the clock and around the world to get the network back into health as quickly as possible. Now, you've probably heard Satya say that Microsoft loves Linux and Microsoft loves open source. In the networking space, we're actually living that. For 10 years now, we've been driving an effort called SONiC, Software for Open Networking in the Cloud. As you've seen, Microsoft runs data center networks with over almost a million network devices. They all have to run an operating system. And rather than running an operating system from any one specific router vendor, we're having them run SONiC. And SONiC is open source. It's used by many companies around the world. We give it away for free. We participate as part of the larger SONiC ecosystem because we have this belief that the more people who are using this software in their production networks, the more battle tested it gets, the more reliable it becomes. Now, SONiC itself is designed as a container-based operating system, which makes it very easy for us to upgrade it. One of the things we like about it is as we need to deploy new features, new sensors, new telemetry into our network, Our routers out there running SONiC, we can create new containers, deploy them, and get those new capabilities running on our networks quickly. It's enabled us to produce new insights into what's happening on our networks, as well as deploy new availability mechanisms that our customers benefit from. So for example, use multiple redundant links inside of our network in new and clever ways. Spread traffic out across our network. Understand where bursts of traffic might be coming from, and take actions to mitigate those quickly. As I say, SONiC was originally began at Microsoft, but it's now part of the Linux Foundation, the SONiC Foundation, and there are many, many companies who participate in the SONiC ecosystem at all parts, from either providing the ASICs that actually go into routers that then run SONiC, producing the routers that will use those ASICs, adopting it to building production networks with SONiC in them, or then writing systems and services to help people who are using SONiC-based networks actually gain the insights that I was talking about so they can run their networks better. Satya stole a little bit of my thunder earlier during his keynote, but Hollow Core Fiber is a physical layer innovation that we've been driving here in Azure Networking. In a typical fiber cable, light flows through the middle of the cable, but interacts with the glass molecules or the glass particles that make up the core of that fiber. Goes about 2 × 10⁸ meters per second in a standard glass fiber. Now, people have known, well, for a long, long time, that light goes 50% faster in a gas or in a vacuum than it does through glass. But nobody could actually produce the equivalent of a fiber optic cable where light would travel through a hollow core. Our engineers, working together with university researchers, have solved this problem. We figured out how to build a fiber that looks like that cross-section picture on the left, where the core is hollow, filled with an inert gas, but it's surrounded by a bunch of carefully designed micromirrors, essentially, that keep the light moving through that as it goes. Now, to realize this, we had to go build our own fiber fabrication facilities. We're manufacturing our own fiber because nobody else on the planet has this technology. But we're productizing this, we're putting it into the ground, which reduces the latency of data traveling inside of our data centers and between our regions, providing never before had capabilities. That's the kind of innovation that you can expect to continue to see from Microsoft. We're going to figure out how to make this available to you so that you can get the literally best-in-class experience on top of the networks and the services that we're building here at Azure. I'm going to hand back to Narayan now, who's going to come up and tell you about some of the services we have in Azure Networking and how we can use those today to help your customers build better services. Thank you.
Thank you, Dave. That was quite a bit of a lesson and things that you can take back and feel good about networking, what we're doing over here. Now let's look at what can you do with services and products as you go back home, right? So I know a lot of you have seen this slide. This is our networking services portfolio. I'm not going to talk about that and bore you. I expect you to know about these things. What I'm going to do instead today is talk about some of our priorities, some principles in which we operate. That is, like Dave said, security first, job number 1, quality, resiliency, and scale, and also innovating into the future. So I'm going to walk you through these different priorities and then talk about what enhancements we are making against these pillars. So let's start with security. As you heard Satya talk about today morning, secure future initiatives is number 1 thing that I've never seen. The whole company is aligned on ensuring that we do things secure by design, secure by default, and secure operations, right? So that's the 3 fundamental principles. Today, I'm happy to announce a few things that we are doing from the networking side that aligns with it. First of all, I want to announce network security perimeter, a public preview as of today, available in all regions for as many as 7 PaaS services and resources. So what is this? Before I tell you what this is and how we can use this, let me see in a show of hands. How many of you use Azure Private Link today? Great number, right? So use Private Link to secure your PaaS resources, right? So you go put a firewall on this PaaS and says, no one can talk to it other than my virtual network, private endpoint, right? Using that, your VNet can talk to it and your on-prem can talk to it. However, all of you probably also have needs where another PaaS instance of yours needs to talk to it. How many of you have that need? Like, so storage wants to talk to SQL, or most times, you're storing your keys in Key Vault, and storage has to go out to Key Vault and retrieve that key, right? The PaaS to PaaS is always a need. And how do you, allow for that? Today, either you can leave it open, which we don't recommend and we don't want you to do, or you can use this trusted services if you have used that. So that allows the entire PaaS service access to talk to your PaaS instance. Of course, you got to have credentials, but you're allowing the service to talk to it, right? Now, this is not as granular as you would like it to be. That's what network security perimeter solves. Today, what we're introducing is a new type of firewall for PaaS services. If you know how NSGs works for VMs, that's how network security perimeter works for PaaS resources. So you can create a network security perimeter resource, and you can add all of your PaaS resources into it. So you can add your SQLs, your storage accounts, your Cosmos DB, your Key Vault, all of it into the perimeter. By default, within the perimeter, communication will be allowed. So you do not have to open any extra ACL, right? Just if you put them within the perimeter, they all can talk to one another. And you don't need to, and they're only allowed to talk to the instance of it, not the entire service. Like your storage account can talk to your SQL DB. So how do we do that? So we are using a combination of MSI and network identity. So all of these resources use managed service identity, which is basically an AID concept. So as they have these identities, we add a network perimeter ID to the MSI, to the token. So we add another claim to the MSI. And every time this instance talks to anything outside, we pass on the network perimeter ID in the packet. So as now we have network ID on the packet, on the destination side, we're able to do filtering. We're able to do filtering to allow communication from the members of the same group. And we can also do allow and disallow any traffic ingress or egress. So now this, for the first time, we are giving you full ingress, egress capabilities on your PaaS resource. If someone is doing some export from your storage account and you want to block that, you can do it. And another good thing is this gives you a centralized firewall. So let's say you have like 20 PaaS resources, and you need to allow some on-premises IP to talk to all the 20 resources. What do you do today? You go to each of the firewalls in the PaaS and open that IP address. No more. You don't have to do that anymore. You can put all the 20 into the NSP and have a single list of IPs to allow to NSP, and it distributes to all the resources, just like how NSG works for VMs. On top of this, we also are giving a full centralized logs. So you can go and look at anyone accessing your PaaS resource inbound or outbound, and you can get all the logs in one centralized place. Now let me show a demo of this. So I'll be pausing as the demo progresses, but I'll tell you what's going on here. So here, we first start with creating an NSP resource from Portal. You can go look up network security perimeter. It shows up. It's not working. Are you able to see it? Yeah. So, and you can create, it usually has profiles, and you can have two modes, a learning mode and an enforced mode. By default, it's a learning mode, so it's not really active, but you can turn them on to an enforced mode where the access is only allowed if, if the NSP has rules in them. So you can put enforced mode on all these PaaS resources, right? So next, you can see how within the perimeter, services have default access. So this is the example of a storage account going to Key Vault to retrieve the key to encrypt the data that it is storing. So without any additional configuration, just by having the storage account and the Key Vault in the same network security perimeter, it's able to retrieve that key and do the encryption that it needs to do. So you don't have to open any extra firewalls to make this happen. So here you see operation was successfully done. See, the third thing that I also want to show you is the NSP logs. So if you go to the portal over here and go to NSP logs, you can see the full list of who talked to your PaaS service, both inbound as well as outbound. So for all 20 or 30 resources that you have in the NSP, there's one place where you can see the logs from. Now, let's look at the last scenario, which is preventing access to go egress. So data exfiltration protection. So let's say for a storage account, you don't want to enable anybody to export data outside the perimeter, right? And someone is attempting to do an export on storage and take them to the different blob that may not be your corporate blob. So you come here and deny that egress access. So now you see that when somebody attempts to actually export that data outside, NSP will kick in and kind of deny that particular operation and say, because of NSP, you're not able to take any data outside. So again, everything is logged back to the NSP access logs. So you will have a way to look at it later time as well for auditing purposes. Cool. So switching gears now. Thank you. So Azure DNS, of course, it's been an important service that everybody uses. We're happy to announce DNSSEC in public preview as of today. So I know a lot of you have been asking for it. So we heard you, and there you go. So, and we're going to make it. I'm not going to tell you what DNSSEC is. All of you know what DNSSEC is. It gives you extra level of authentication and encryption to validate to avoid DNS cache poisoning and whatnot. We're going to make it super easy to enable this. So from portal, there'll be an easy one-click option for you at no extra cost. You can enable that, and then your DNS zones that you are hosting in Azure will have DNSSEC capability added to it. Cool. Also, to round out the security section of it, I'm going to talk about Azure Bastion. Of course, you all know Bastion. You all love Bastion. We know how good the adoption is for Bastion. Couple of things I want to tell today. One is we're announcing general availability of Bastion Premium. So this was a SKU that was available in preview for the last few months. We're taking that to GA, making it available in all the regions. Of course, it has all the Bastion features that it usually has. Couple of new ones. One is you can use it for session recording. So great for auditing purposes. So later on, you can go and see who logged in, what did they do, what happened in the particular session. Great tool for auditing. We're also going to make this private-only Bastion, which means there is no public IP address anymore to come into the Bastion. Even that part is eliminated. So from within your on-premises network or from a VNet, you can use a private IP address to get into Bastion and then RDP into any of the VMs that you want. That's available in GA. Bastion Developer is also generally available now. This goes back to our principles of secure by default. So this is offered to you at no extra cost. This is going to be available for you as a mechanism to remote in or SSH into any of our virtual machines that you have in Azure. Right? It will be available just from the portal, just like where you add a public IP and do the remoting. Instead, you can use the Bastion Developer SKU to directly remote into these machines. It will give you one VM at a time per session. We want to limiting that from a limit standpoint. However, it's available for you to use for free. So that's another announcement for today. All right. So that is security. Now let's talk about resiliency. Again, a great set of announcements here. So number one, Azure ExpressRoute. Metro SKU is generally available as of last few months. So Microsoft, and we have always recommended customers to use maximum resiliency when connecting to Azure via ExpressRoute. We always recommend you to at least go and peer with 2 different regions to come back to, and then have 2 different edge sites. But many customers are regional. They're only in one region, and they end up just having a single connection to Azure. It's still 2 circuits, but all connected via the same edge site. So when this edge site goes down, then there is downtime for you until the edge site recovers. Now we're announcing Metro SKU. So what you can do, take those 2 circuits, the 2 connections, run one through one of the facilities, maybe one part of the city, and the other to the other edge site in the same city. So in metro urban centers, you typically have more than one edge site. So that you can split your connections via 2 different edge sites and then still connect back to the same Azure region, thereby increasing your resiliency and not being prone to failure from a single edge site. We're also announcing or making this the migration very easy for gateways. So if you have a zonal gateway with 0 downtime, we allow you to upgrade to zone resilient gateways at no extra cost. So that is also generally available for you. And the last but not least, the scalable gateways, where you can have auto scale gateways that can support up to 40 Gbps via ExpressRoute. So these are all great features to add on to ExpressRoute to improve your resiliency. Load balancer. So one of the most fundamental services in Azure is Azure Network Load Balancer. Almost every customer uses that. And for the longest time, they asked us a way to manage probe health. So today, you can probe down a particular instance. You have custom probing available. So within 15 seconds, you can probe down a particular instance. But customers always wanted a way to, through API, manage this. Why? Sometimes they have scheduled maintenance. They proactively want to take down a particular instance. So now we're offering you an API, which is a kind of an alternate control plane through which you can take down a particular instance of the, that is behind the load balancer, right? Even if your probes are not working, and if you haven't gotten your probes to work really well, you can use additional ability to go down and probe it down. So it's a great admin capability for you. Also, we are expanding a load balancer to work cross-subscription. We have heard you many times. Customers have multiple subscriptions. Backends are in one subscription. The networking team operates a different subscription. They want to do the load balancing across subscriptions. You have it now. So we are also generally available, the cross-subscription load balancing capabilities. So you can add that as an extra layer to add resiliency and flexibility to your deployments. All right, now we're going to look at some of the announcement under the scale, so to enable you to operate at a higher scale. First, I'm super happy to announce we are announcing 1 million IP addresses in a VNet. Can you imagine 1 million IPs? Who needs 1 million IPs? Only a few. That's good. because we don't think everybody needs 1 million IP addresses. In fact, we support up to 512K IP addresses, and we don't have enough customers using that many virtual machines in Azure to use them all. However, there is a good use case. We do see customers using Kubernetes-based AKS deployments or on-demand bursting, where many pods come up, and they all need IP addresses to talk to one another, right? So for that purpose, we're announcing what is called as an IP prefix on a NIC. So as the picture shows you, typically you assign /32 IP addresses to the NIC, and you can get 30 of them. Now you can actually assign a prefix to the NIC, so a /28, which gives you 16 IPs right there. You can add 3 such blocks to it, and then you have 2 extra IPs, makes a total of 50 IP addresses on a particular NIC. And we do this because we optimize the routing on the backend to provide the scale for you. So what used to be 64,000 IP addresses now goes 16 times, and you can get up to 1 million IP addresses. And there are some customers, believe me, who do want to use this. But anyways, for others, for futuristically, you don't have to worry about this anymore. You have 1 million IPs to use within a VNet. All right. So this is something that I want to talk about, as not everybody knows about the use of it. This is accelerated connections, right? Again, the use case for this is, as you have higher VM sizes within Azure, we give you more connections per second limits, and we give you more total flow count that we can support, right? We still have to have a limit because all the VMs in the same host are sharing the hypervisor, right? So they all have to share the common memory and common processing power in the Hyper-V. So if you take the entire node, for which you have to pay a lot, then we can give all of the host processing power to that single virtual machine. So you can have a higher connections per second, higher flow count. However, not always that customers want a higher CPU power. They want higher networking capabilities, though. And this is so true for NVAs, like if you're running a firewall or a load balancer, you're seeing a lot of connections through, right? You don't need a lot of computing power, but you need a lot of networking power to have a lot of connections and a lot of flow limits maintained. For that, we are announcing what is called as accelerated connections, which is irrespective of the VM size. Even if you can take a small VM size, but you can opt for a higher SKU of accelerated connections, which will, the way that we are doing this is we will let the traffic go through a network appliance, a hardware network appliance. We're offloading the traffic to that. And you might have seen us, we have a lot of partnerships with our DPU partners like AMD. So we have separate appliances stood up that has powerful DPUs in them that can process high networking power. So we do the offload there, and thereby we can offer you greater connections per second, greater flow limit. So you can use these things if you have NVAs and you need more of a limit. You can use this instead of going on higher on the VM size itself. That's generally available in some regions. All right, so I also want to quickly talk about the IPAM feature of Azure Virtual Network Manager. So many of you have said that. How many of you still use spreadsheet to manage IP addresses across multiple environments? I see a few hands. No, come on, don't be shy. Yes, there are a few people, a lot of people who actually use spreadsheets for managing IP addresses, right? Now, we're announcing the capability to do automatic IP address management, where we can actually help you manage IP addresses in Azure, also across Azure. You can reserve IPs to be used outside Azure, and we can give you analytics usage data for that. And we can also make sure there is no overlapping IP addresses that you'd end up using. That way, kind of keeping you, keep the routing intact for you, if at all you want to talk to other VNets. It's available through AVNM. It's in public preview, soon to go GA. All right, so let's talk about some exciting new things we're doing in Azure networking that's geared at the future. First, you heard a lot about Copilot today morning in the keynote from Satya. So networking is not to be left out. So we're adding a lot of Copilot skills to our Azure Copilot. So these will help you decide about a particular product in Azure networking if you want what you want to choose. It'll help you troubleshoot issues. It'll also tell you some stats that you may not easily get outside. So thing that you need to understand is this is the UX for AI, right? Like Satya was saying. So it'll actually bring to to light some of the capabilities that we have that you may not know that well. So in an interactive way, but you can ask questions and it will bring that out to you, right? So this will leverage all the networking products and skills that we are building on the back end. It'll bring it to you in a more user-friendly way on the front end. So let's look at a quick demo for this. Okay, so here you can go to the portal and ask for, hey, I want to use a firewall, but I don't know which one to really use. And suggest me what best queue to select. Now, Copilot is going to ask you specific questions to find out more about what is your profile, what are you really looking for it, right? What do you really want from it? So it's kind of doing a comparison with all the SKUs that we have. And based on your answers, it's going to recommend a particular SKU for you. And then it'll give you more information about how you can leverage that SKU, how you can use it better, right? So instead of you going through many documentations and different tables to compare, it's right there for you. A very basic but a good feature to have. Next, it's also going to show you some topology between different VMs. For example, you have two different virtual machines. You're wondering, how do they talk to one another? What's the topology behind this? Is there a firewall in between? Is there a load balancer? Do I have NSGs? I just don't know. You can just go to the Copilot and say, can you show me the topology between these two virtual machines? And then you go select these VMs. And then you say, OK, show me the topology. There you go. It's going to show you, OK, here is VM1, VM2. Here is what you have in between. So that way, you get a pictorial representation of your deployment itself. Then it'll also help you debug some tough networking problems. As always, people say, difficult to debug networking issues. So you have connectivity issues between on-premises and Azure. You can go to Copilot and say, no, I'm having issues. Can you help me with this? It's going to ask you to select the VM, and let me see what is going on over here. What's your on-premises? It's going to find out you have an express route circuit. It's going to go look at the express route circuit, ask you to pick which ER circuit you're using. It's going to run some diagnostics behind the screens for this with using our tools. It's going to do some data crunching for you. And then it's going to come back and identify the problem that you may be having. And it's going to let you tell you about it over there. And then probably also tell you what you could do to mitigate from these problems. The last one is you have probably an endpoint or IP address. You're wondering, is there an attack going on? Who is really talking the most to this IP address? If you want to know things like that, you can just go ask, pick up an IP address and say, hey, show me the top 10 attacks for these IP addresses. It's going to go and, again, do some data crunching. It's going to come back with all these IPs, along with a number of times it has talked to you in the recent time to kind of give you a view of what attack could be going on over there. So there you go. So you try it out. And there are a few skills, and we're constantly adding new skills also. So watch out for what we have in the Copilot. OK, few more. OK, so this is something we announced at KubeCon last week. So we are also announcing what is called as Advanced Content Networking Services. And this is really if you're using pods and using AKS or non-AKS, if you're using or Azure CNI. So we had released Azure CNI, and a lot of customers use Azure CNI. That is off of open source Helium. Now we're taking it to the next level. So we are giving you more insights, monitoring, and metrics at pod level. So that usually at the VM level, you have a lot of metrics available to you, and but pod level, you usually don't have that rich of a metric. So this, ACNS, built on top of open source Retina, gives you full rich information about every pod, who's the pod talking to, what are the metrics, and whatnot. It also gives you FQDN-based filtering at the pod level. So even for VMs, you do not have that in NSGs. If you need FQDN-level filtering, you have to use other firewall mechanisms. But for pod-level filtering, since we can do that on the host machine, on the VMs, we are giving you an FQDN-based filtering for pods, where you can use it effectively to deny or allow particular FQDNs for egresses. So generally available starting last week. Also, last topic, we're also Azure Extended Zones. We're announcing Los Angeles, location and GA. So this is, Azure moving to edge sites. Think of it that way. So this is, the scenario here is, especially in LA, it's a remote artist, workstation. So they want to get, low latency, powerful compute accessible to them. So we have GPU-based VMs in an LA facility, and so that the user to the VM is less than 10 milliseconds. And so that's available for, in GA. You can try it out. And I want to recap all that you heard. So here are some of the things that actually go back. Definitely look at network security perimeter, see if you can adopt that. Do not use public IPs, please, for your accessing virtual machines. Use Bastion instead. Definitely look at your Expresso resiliency, where you are in that. We are actually helping a lot by, for you to go to maximum resiliency. Do that. Definitely look at IPAM and AVNM to ease your, your IP address spin. And then, try Network Copilot. Give us a spin. And here are some related Ignite sessions that we have. Please, make sure to go and, attend them. We have a session coming up tomorrow. We talk about ER resiliency more. Tomorrow at 11 o'clock. We have another one on network security. Now, that's something that you want to go and, attend as well. Here is a booth, so our, all of us over here, product team, will be available and talk to us. And now, for any Q&A that we can probably have two. Please, Dave, if you can join me. So you can use the remaining 2 minutes or so for any Q&A if you have. Online is all answered. Anybody here have any questions on whatever we presented, both me or Dave? Here's a chant. There's a mic there.
I have a question. So the Azure Copilot, do you still have to enable that on the tenant level?
Azure Copilot, do we have to enable that at the tenant level? No, it's not needed at the tenant level. I think at subscription level, I think should be available. Yeah. Cool.
Does Azure have any plans for basically doing a cross-cloud connect things like how Google is basically?
Okay, so the question is about, does Azure have ability to plans to do cross-cloud connect? All I can say is, we do want to extend the capabilities of ExpressRoute to go even beyond just Azure. So we're definitely looking into that. Is what I'll say for now. Yeah.
And at the physical layer, we do have very high bandwidth connections between ourselves and all the other major cloud providers.
Go ahead. There's a mic there, yeah.
You have a new service for global secure access that provides public and private access to resources. Could you talk a little bit?
Yeah, that's Microsoft Entra Access that you're talking about. It's identity-based access. Yes, we do have that in GA that can allow you to do public connectivity. And that's actually a hosted service via Azure. It's more on the identity side of things. But yes, you could use that to go to public internet as well as private address in Azure. We have sessions as well in Ignite. You may want to go there for detailed deep dive.
Quick follow-up. I don't know if it's the right forum for that, but is that something that eliminates the need for corporate VPN?
I wouldn't say it eliminates the need for corporate VPN. It's a different way to use, based on your users, and it still uses VPN underneath. So yes, you could try it to see if that, meets your needs.
We'll also have people from the Azure networking team at the hub. So if you have specific scenarios you're interested in, stop by, talk to us, and we'll work with you to figure out a solution.
Cool.
All right. I was wondering when we will be able to route or firewall the Azure Bastion subnet, since a lot of our customers are wanting a secure network design, but you cannot apply routing tables or firewalling to the Bastion subnet. Is that on the roadmap or anything?
That's on the roadmap. So I get a nod from the PM lead for that yes. So we're going to have that person right there. So yeah, we're going to have routing capabilities that you can apply route tables to Bastion subnet, yes.
All right.
Last question. Good. I did not get that question.
Yeah, they're throwing us out, so just coming up and we can ask separately.